As students, whether upper year or lower year, we struggle to choose our courses at every step of our university career. There are lots of factors that affect our decision: the professors, how well we think we'll do in the course, our interests, and the list goes on. We first started by creating a survey that will be released to students in our campus to gather data about their grades in certain first and second year science courses. Our project will mainly focus on studying 2 first-year courses from every science major in the sciences faculty, which are computer science, math, physics, biology, and chemistry. We also decided to gather data from students who have completed only some of their first-year courses. These students will serve as our experimental group. We will use this data to predict their grades for their potential second-year courses.
Here's a quick overview of our project, just in how we will utilize certain techniques learned in this class to implement certain parts and return a desired user's major and predicted grades. So let's begin with the student here. So the first thing he does is he'll put in his grades, and we handle basically the rest from here.
After extracting the data, we needed to generate a similarity matrix to classify which students are similar to which students based on their grades. We used the cosine similarity approach to create this matrix. We then used the similarity matrix to help predict the grades of the experimental group using collaborative filtering. After completing this first milestone, our next goal is to generate a more accurate measure of how well a student may do in a course and their enjoyability. We aim to use a Bayes-net model that will take into account the student's interests, experience in the current faculty, and their predicted grade. This model aims to produce 2 important outputs: course enjoyability and, for lack of a better word, aptitude, which we defined as what the student will most likely score after taking external factors into account.
And that will help us further in our next technique, which uses a predicted utility function to find out which major is best for them. So, of course, we are not going to use the Pythagorean theorem for this, but we will be using some quick maths, and through that we'll be able to predict the best major based on performance, best major based on a balance of performance and enjoyability, and a major based specifically on enjoyment. So using all of these pieces in the system, it will allow us to predict the user's preferential major, their predicted grades in a class, and their overall enjoyments of a major. That about concludes what our project is going to cover. So now we'll be taking a look at the collaborative filtering portion of this project. So what we have implemented for you today is the grade prediction for a given student. So you can see here, they enter their name, the class mark that they want to predict, and then they enter the CSV file that's generated from completing our survey and then getting cleaned and such by our program. So we have a student here. He's only taken 5 courses. What he's currently taken is Computer Science 111, Computer Science 121, Math 100, Math 101, Physics 111, Physics 121. So he's just taken some first year comp sci prereq classes. Hasn't taken chem, unfortunately for him. He's going to find that out the hard way, then he needs that. But hey, that's what this app is made for in the end. So given those marks that we have stored internally right now, we're going to put it up against a table of other students' grades and use cosine similarity to find the most similar students. Then we'll pass that through to a predictive equation to get his predicted grade based on the slides we had in class, i.e. his mean grade as well as the differences in grades between all of the people who are similar to him based on this class. So let's put him in here. His name is Tim. Oh, goodness. There we go. Class mark we want to predict. Let's go with Math 200. So I would technically supposed to put in the CSV file by pressing this and entering my file. However, it's already stored internally for the purposes of this demonstration. So I just hit the predict button and boom. Okay, so he would get a 77 in Math 200. So he got a 77% in Math 200, or he will, predictively based on the other students in this table. And so That makes a lot more sense when you see that he got 50% in Math 100 and 69% in Math 101. So it looks like his marks are improving, and it seems like people tend to do better on Math 200 than they do in Math 100 and Math 101. From personal experience, I can say that is true. So yeah, looks like little Timmy here is going to be pretty happy when he takes Math 200. And that's all we have for you today, just the collaborative filtering. Coming next is going to be the rest of the project. Thank you very much.
You can follow the progress of our project on our GitHub. Link will be posted in the description. Thanks for watching.